Hello, today we're going to be looking at the three non-parametric hypothesis tests and looking at how to choose which one should be used when. So those three tests are the sign test, the Wilcoxon signed rank test, and the Wilcoxon rank sum, also known as the Mann-Whitney U. These are all non-parametric, so you might be asked to do a non-parametric hypothesis test, but it doesn't say which one to do. You need to be able to choose the right one and be able to justify why you've used that test. So the sign test, just a quick recap. We decide if the value is higher or lower using the plus, the minus, or if it's the same then we use a dot. Always use a binomial model, x equals b with the probability of 0.5. That n value is the number of pieces of data that aren't equal. So that's the number of pluses or minuses, but not including the dots. This is always testing for the median, which is the eta symbol, and can be done with non-numerical data, can also be done with paired data. For the Wilcoxon signed rank test, we're not just seeing if it's higher or lower, we're calculating how much higher or lower. Then ranking the size of those differences. If you've got a +1 and a -1, and those are two that are closest, then they get the same rank. So we ignore the signs in this case. This tests for the median or the mean. This is because if it's symmetric data, the mean and the median are going to be the same. Again, this can be done with paired data. For the Wilcoxon rank sum, or the Mann-Whitney U, this uses two samples of unpaired data, and these can sometimes be of different sizes. So you might have 10 pieces of data in your first sample and 6 in the second. You can also do it with the same size sample sizes. We rank all the data as one group, and then there's the U formula, which is using the totals and the multiplying the sizes of the two groups, M and N. That formula is in the formula book. So that's a recap of the three tests we can be asked to do. When we're looking at a hypothesis, we need to think about the number of variables, the number of samples that have been used, if the data is paired or not. Also good to have a look if anything stands out in particular about the data. Okay. So this hypothesis test here doesn't say which test to use. It just said investigate. Okay. We've got to find out how many variables there are. What is the variable? What is being measured in this test? Well, this is the emissions from the car with the device. This is also emissions, but from a different sample from cars not fitted with a device. Okay. So there's only one variable, and that's emissions. How many samples? There's two samples. Cars with a device, cars without the device. Is the data paired? Well, we can see we've got 6 of each, but is there a link between this value and this value? Is there a link between these two or these two? There's no titles to say this is a particular model of car. So this is a Vauxhall, this is a Ford, this is whatever. We're just told that there are 12 new mid-size cars. They've got the same engine size. 6 of them with the device, 6 without. So this data is not paired. We've got 2 separate samples testing for the same variable, the emissions. Okay, so for that reason, we're going to do the Wilcoxon rank sum. Okay, we've got 2 samples, the same variable, but the data is not paired in any way. This is another one that is unusually set out hypothesis test, which can be a little bit tricky to work out which one to do. 6 students from school A, 6 students from school B. And they've done a statistics exam. and they've been ranked on their marks. Okay, so this could have been presented differently. We could have been given their scores and then asked to rank them, but they've already done the ranking here. Okay, so to me that's something that stands out, that it's already been ranked. So I'm thinking I'm going to need a test that's got ranking in it. There's only one variable, which is the school, the mark. Okay, and then it's been split into their ranks by school. Is the data paired? Well, no, there's no pairings going on here. And the two samples are from different schools. So we've got two samples and we're looking for unpaired data. We've already got a ranking sorted out. Okay, so we're going to do the Wilcoxon rank sum again on this one. We're going to give these ranks here together. All the B's we're going to add up. Then we're going to add up all the A's. And then we're going to use that formula. It also talks about the difference in the average marks. It says average, it doesn't say mean or median. So that's another clue that we could have a choice there. Next, another hypothesis test question. Again, set out with two rows of data. This first row is max, this second row is min. Okay, we can see some kind of link here. January, February, March. So each of the months links these two pieces of data. We're testing for an association between the maximum and the minimum. Is there an association? So what are the variables? The average maximum monthly temperature is U. The average minimum monthly temperature is V. So we've actually got two variables here. And that's something different from the last hypothesis test we've done. Okay, so we've got two variables and we're testing for an association between those variables. We haven't been asked for a difference or a reduction like we did in the previous ones. Data is paired, okay, but because we've got two variables, it is bivariate data. Okay. So these two values are both for January, but they're measuring different things, the minimum and the maximum. Okay. So testing for an association, it could also say correlation, and that keyword there with the bivariate, two different variables, even though they're both temperatures, one's a maximum, one's a minimum. Bivariate. We're going to do PMCC on this one. So this isn't either of the three non-parametric tests, but it's an example that shows you that the data can look similar. If it said, is the maximum higher than the minimum, then we could do a sign test, or we could do a Wilcoxon signed rank test and say, yeah, that one's higher than that one, plus that one's higher than that one, plus. But we've been looking for an association between the two. That's why it's PMCC. Last one to look at. Accounts manager looking at football shirts throughout the year. He says that's increased. We've got our values in thousands, so be careful when you're interpreting any data. Data is known to be symmetrically distributed. For me, that's something that stands out. We've got this assumption, so I'm thinking, which hypothesis tests require that assumption? Okay. How many variables are there? Only one variable, and that's the total amount of money coming in from shirt sales. We've got it from 2 different years, and the data again is paired. August, September, October by the months. Okay, so paired data. We're looking for a change in the take-ins. This one's going to be the Wilcoxon signed rank. Big clue for this one is that the data is known to be symmetrically distributed. If we didn't have that statement there, we could do the sign test other questions like this would ask you to state any assumptions. Hopefully that helps you think a little bit more about which test to use when. There's going to be some more practice of this later on.